Hello students, welcome back to JAWA, and this is Force Part 2. So, in the previous video, we discussed if a force is applied to a body, it can do two things. Either it can undergo linear motion or it can undergo rotational motion. And we even saw what are the conditions for it and what affects the direction of rotation of a body. So today we are going in detail about it. So we'll start with moment turning effect. So if I apply a force on a body or an object, and if I draw the perpendicular to my line of force, I repeat, if I draw a perpendicular to my line of force and join it to the pivoted point, then the object or body will rotate perpendicular to this perpendicular. I repeat once again, if perpendicular is drawn to the line of force or to the line of action of force and I join it to the pivoted point, this line, let me name it as X. So the body is gonna rotate perpendicular to X. Okay. So next, factors affecting the turning effect of a body. So what are the factors affecting the turning effect of a body? When do you think a body is gonna rotate more or less? So the magnitude of the force applied affects the turning effect of a body. If I apply less force, the rotation is less, and if I apply more force, the rotation is more. And the distance of line of action of the force from the axis of rotation. And you may have tried this in your daily lives. You start pushing a door from if you push a door at the end, it easily rotates, but as you go nearer to the hinges and as you apply a force near to the hinge, the force required to turn or rotate the door becomes more. That means at the end of the door, the distance, at the maximum distance from the hinges, you need least force to rotate a body. If you go further towards the hinges, you need more force to rotate the same body. And the distance of line of action of the force from the axis of rotation also affects turning effect of a body. The more the distance of line of action of force from the pivoted body, the least the force required to turn the body, and the less the distance from the perpendicular from the line of action of force to the pivoted point, the more the force required. So if more is the distance between the pivoted point and the force, the less force you need to rotate that body, and if the distance between the pivoted point and the force is less, you need more force to rotate that body. So one more important thing, what is moment of force? Moment of force is the product of force applied and the perpendicular distance of force from the point, that is pivoted point, and we give this a special name, torque. The torque usually means power, so we give the moment of force a new word, torque. Moment of force or torque is equal to force into perpendicular distance of line of force from the pivoted point. In the term of definition, the moment of a force or torque is equal to the product of the magnitude of the force and the perpendicular distance of the line of action of force from the axis of rotation. Simple, right? So Let us see the unit of moment of force. As you know, unit of force is Newton and unit of distance is meter. And since moment of force is force into distance, so we take the unit of force and the unit of distance, which is Newton into meter. And hence the unit of moment of force is Newton meter, and the CGS unit of moment of force is dyne centimeter. And now let us look at a very important relation between Newton meter and dyne centimeter. So 1 Newton is equal to 10 to the power of 5 dyne, and 1 meter is equal to 10 to the power of 2 centimeter. So 1 Newton meter is equal to 10 to the power of 7 dyne centimeter. And a special case, if force is measured in gravitational unit, then the unit of moment of force in SI system is kgf. The SI unit becomes kgf into meter, and in CGS system the unit is gf into centimeter. So let's now look at the relation between kgf into meter and Newton meter and gf centimeter and dyne meter. So 1 kgf into meter is equal to 9.8 Newton meter, and 1 gf into centimeter is equal to 980 dyne centimeter. So I think it's now clear to you. And moving on to our next topic, clockwise and anti-clockwise moments. If a body is turned by a force, it rotates in two ways. One, in the clockwise direction and in the anti-clockwise direction. So what is this clockwise and anti-clockwise movement? When a body rotates, the direction of clockwise movement is along the axis of rotation inwards, which means the clockwise movement is along the axis of rotation and it seems to move inwards, while the direction of anti-clockwise movement is along the axis of rotation and it seems to move outwards. Okay? And as we have already studied, the direction of rotation of a body depends on two things. Firstly, the point of application of force and the direction of the force applied. So I think it's really clear to you now. Okay? So moving on, let's see the common examples of moment of force in our daily lives. We use moment of force to open a door, to shut a door, and we also use for turning a steering wheel and for pedaling bicycles, and even we use it in spanners, etc.